All right, so the last token was the bonding curve token that we looked at, and now we're going to look at the vesting token. It starts pretty much the same, except that this time we're using ERC721, which, if you remember, was the non-fungible token ERC, and we again use 1363. Our vesting contract is a non-fungible token which can receive 1363 tokens. And again, we are using safe ERC20 for similar reasons as last time. Then we have this additional event called vesting claimed because sorry, we allow people to claim their vesting using the claim function. And we have to make an event for that just so it can be I'm actually just looking at that. I might actually want to revise this event so it also lists the recipient or maybe the vesting token used, but that's fine for now. Then we have this struct, which is like a custom type formed from those fields, which is the data for a specific token. And it holds things like the total value of that vesting, the amount we've released, so the amount we have paid out of the vested amount. Then we have the start block, like we have to, the vesting starts being like paid out when we reach that block. And then we have this period count and period blocks, which we use to like split the vesting into period count plus one pieces, and then each of those pieces is paid out in that amount of blocks. Actually, just to make a picture of it. Whoops. So we first wait until the start block, and then we have period blocks for a period count amount of times, and the amount that is withdrawable. So we have a total amount of the vesting. So let's say this is the total amount, which we split into period count plus one parts. So in this case, this will be 4 parts. And afterwards, we will give that much out after the start wait is. So like after, at this point in time, after the start block is reached, we give the first portion, like we make it available for withdrawing. Then we have the second portion, and so on. And at the end, like when the whole thing is finished, we release the total value for withdrawing. So this is the withdrawable amount. Anyway, to keep going with the code, like this should become a bit clearer by the end. We then have the state of the contract. We have the base token, which is like the token we are vesting into the vesting contract. Then we have some token data for the different vesting tokens. So for each of the NFT tokens, the ERC721 tokens. And finally, we have this next token ID, because we have to keep track of that ourselves, it seems. Then we just have a constructor which calls the base ERC721 constructor for the name of the symbol and just sets the base token here. Then we have our minting functionality, which is implemented in 2 ways, like with an ERC1363 receiver, where we expect to receive tokens from the base token, and we decode the data that has been sent with the token to guess who the receiver should be, what is the start block, the period count, and the period blocks. And we just go ahead and mint the vesting for that. And actually I have duplicated functionality here. Wow. Anyway, going on. This should be cleared up after the video. We have this mint function which does perfectly like the same thing, except it uses safe transfer from to get the funds into the contract. And finally we have this mint vesting function, which creates a new vesting. And for that, we first like get a unique token ID for the NFT token. We do some defaults just in case, so nothing breaks later on. And then we create this vesting data. Here we directly create it in storage. So when somebody says like vesting data storage, this is a pointer in a sense, and we directly make it point to the data in the mapping. And then we just set the different parameters of the vesting data. And finally, we mint a token to the receiver. And this comes from the base ERC 721 contract, which can be found in OpenZeppelin. But it basically keeps track of owners, balances, and so on for a proper ERC 721 implementation. After the token is minted, the receiver can then transfer the token to other people and so on as intended, or they could claim the token. And here, make sure that the one who is claiming the token is either the owner of the token or is approved to use this token. And since actually approval also allows one to transfer, we're fine with allowing the approved people to also claim the token directly and like claim the amount in the token. And we also have this claim and call for using ERC 1363 base tokens. And afterwards, we just have this claim implementation where we take the the data of the token, we calculate the value of the vesting, like that is the withdrawable amount. We make sure that we don't release anything twice. If we are going to release the whole value of the token, we just burn the token. And finally, we make a call if needed, like we call transfer and call or transfer to give the funds to the receiver, to the one the token is claimed for. And finally, we have this calculate vesting value function, which does the whole thing we drew here in the graphic. It takes like the current block, the total value of the vesting, the start block of the vesting, the period count, and the period. And like if we're before the start block, then there is no value of the vesting, like it is all vested. And, we calculate the current period, like how many blocks after the start we are, divided by the amount of blocks per period. And then we either return the total value if we are over the total period count, or we calculate what like fraction of the value we should release here. And I see I'm not dividing the period blocks plus 1 here, or like period count plus 1. So it is possible that I have to double check this part. Apart from this, the vesting contract is relatively decoupled from the other contracts and just vests given ERC20 token. And that's about it for a quick review of the vesting contract.